Question number 1. Track is given, winds are given, task, total distance is given. What are the time and distance to the point of equal time between A and B? So point A is here, point B is here. The total distance between point A and point B is 350 nautical miles. 350 nautical miles. Let's say this is a critical point. Outbound track is 355. So inbound reciprocal track will be 175. Now going outbound task is 140 knots. Winds are coming from 340 at 30. Winds are coming from 340 at 30. So we will find ground speed. So let's use GX3. Your task is 140 course 355, winds 340 at 30. So your outbound ground speed is 110.8, or outbound ground speed will be 111. Now from critical point we are going to return to point A. Okay. The task of this aircraft remains the same. We do not have a different task given. Task 140. And now we will find ground speed homebound. So now we will use a track of 175. Other things remain the same. So task 140, course 175, winds are the same. So your ground speed will be task 140, course 175, wind speed 30 knots, direction 340. So ground speed 168.76 or 169 nautical miles. So ground speed homebound is 169 nautical miles. Now let's solve this. Distance to critical point, total distance between point A and B multiplied by homebound speed divided by outbound plus homebound. So total distance 350, homebound speed is 169 divided by 169 plus 1111. So 169 plus 111 is 280. 350 into 169 is 59,150. So that divided by 280 is 211. Time to critical point will be distance to critical point divided by outbound ground speed. So 211 divided by outbound ground speed of 111, that is 1 hour 54 minutes. 1 hour 54 minutes. So 211 nautical miles is this. Option alpha and delta. 1 hour 54 minutes is 74 minutes. So closest option is option alpha. Okay. Next. Question number 2. Now course is A to B 088. Distance is 1250. Task is 330 knots. Winds are given. What is the time from departure to the point of equal time? Similar question. So let's draw the diagram. Point A, point B. The total distance between them is 1250. Let's say this is the critical point here. Going outbound, your aircraft task is 330 knots. Winds are coming from 340 at 60. What is the track? 088. Outbound track is 088. So homebound track will be 088 plus 180, that is 268 degree. And winds are coming from 330. So winds are coming from behind. 330 is something like this. 330 at, correction, 340 at 60 knots. 340 at 60 knots. Okay. Now let's use CXT to find out ground speed. So task is 330. Outbound course 88. Wind speed, 340 at 60. So ground speed is 343.57. Ground speed is 343.57. So I'm writing here outbound ground speed is 343 knots. Now homebound ground speed. Now coming back home, again your true airspeed is going to remain the same. A task of 330 knots as given in the question. They have given 330 knots only, and winds are also same. So what will change is your ground speed homebound. So now use homebound track 268. Other things remain the same. So 306. Ground speed will be 306. So your final answer, distance to critical point will be total distance between A and B divided by outbound plus homebound. So 1250 multiplied by homebound speed 306 divided by 306 plus 343. So that is 649. 1250 multiplied by 306 is 382, 500. Divided by 649 is equal to 589. Time to CP is distance to CP divided by outbound speed. Distance to CP divided by outbound speed. So 589 divided by outbound speed 343. That is 1 hour 43 minutes. या फिर 103 minutes. Okay. So 589 nautical miles and time is 1 hour 43 minutes. So correct answer here will be option Bravo, the closest option. Next, question number 3. Distance is given, track is given, winds are given, task is given. What is the distance? So again, a similar question. Point A, point B. Total distance between them is 340 nautical miles. We have a critical point in center, midway. True track is 320. Reciprocal track or homebound track is 140. Aircraft flies outbound at a task of true airspeed is 110 knots. Okay. Winds are coming from 160 at 40. So 160 at 40. That means winds are coming something like this. Okay. Now let's use CX3 to find out our ground speed outbound. So outbound course is 320, track is 320, task is 110, remember? Task 110, course 320. Winds are 160 at what speed? 40. So your ground speed will be 146.73 knots. That is 147 knots. So your ground speed will be 147 knots. Outbound ground speed will be 147. Now coming back home, you want to come back home. So you will be flying at a task of 110 knots again. Your homebound ground speed will be how much? Now coming back home, you will be following a track of 140, same task 110. So task 140, course 140, speed winds remain the same. So ground speed homebound is 71 knots. 71 knots. Now distance to critical point will be total distance h divided by O plus h. So 340 multiplied by 71 divided by 147 plus 71. So 147 plus 71 is 218. 71 into 340 is 24140. That is equal to 111 nautical miles. The closest option is option Charlie. Okay, 112. Question 4. You're flying A to B, distance 270, track is given, winds given, task is given. Again, what is the distance and time to the point of equal time? So find out. So draw this A, B. The distance between them is 270. We have critical point on our way. Now aircraft is flying at a true airspeed of 125. Write that here. Winds are originating from 120 at 35. 120 at 35. Somewhere from here. Reciprocal track. Outbound track is 030. So if you want to come back to your departure, we will be flying a reciprocal track of 210. So now you have all the points that are required to find out ground speed. So task 125, course 30, winds are coming from 120 at 35 knots. At 35 knots. So this gives you a ground speed of 120 knots. So outbound ground speed is 120. The homebound ground speed will be how much? Task remains the same 125. Course will change. Course will become 210. 21035. Task is 125. 120 at 30 knots. Okay. So again, ground speed remains the same, 120 knots. Okay, whether you are flying outbound or homebound. So let's find out distance to critical point, which is dh divided by o plus h. So 270 multiplied by 120 divided by 120 plus 120. So 270 into 120 is 32,400. Divided by 240 becomes 135 nautical miles. And time to critical point will be distance to critical point divided by outbound speed. So 135 divided by 120, that is 1 hour 7 minutes. Okay, 1 hour 7 minutes, that is 67 minutes. So the closest option here is option Charlie. Question 5. Okay, there is no question 5. This ends the lecture. I hope you have understood this simple 4 questions that I solved, answered, explained. Follow this procedure for all kinds of point of equal time numericals, CPL, ATPL, airline exams. More practice, more confidence, better time management, better confidence. All the best. Please share this video with all your friends who are preparing for CPL exams, ATPL exams, airline exams. They will definitely find this lecture very useful to them. If you haven't subscribed to this channel yet, do it now and hit the like button if you have liked this video lecture. All the best. See you in my next video lecture, in which I will be solving point of no return numericals from this Oxford book itself. See you.